Hello everyone, I want to welcome you to another section, and in this video I want to talk about how to read IR spectrum. Please kindly note that this short explanation is not for, let me say, technical purpose. Probably when you are running experiment in the lab, this explanation might not really be necessary because there are already instruments that can help to read your IR spectrum. But at the same time, for the sake of the course probably that you might be taking, where they can give you an IR spectrum and they can ask you to read what class of compounds can you infer from the given IR spectrum. So in this video, like I said, I will be giving us some of the things that we can always look out for in an IR spectrum in order to know the class of compound that our IR spectrum is talking about. First, IR spectrum is usually divided into two parts, um, which is the functional group region. At the same time, we also have what we call the fingerprint region. Now, the functional group region contains mostly your stretching vibrations, that is, vibrations that has to do with the bond length. At the same time, while your fingerprint region usually contains your bending vibrations, which has to do with the bond angle. But like I said, the major point of focus when you are trying to read an higher spectrum, probably for exam purpose, is the functional group region. So, and that is, let me say, the major point where you have to first consider even before considering the fingerprint region. At the same time, we must note that there are also some stretching vibrations that can also be found in the fingerprint region, where I said we have mostly the bending vibration. And I'm going to probably mention some of a few that we can always check out for in case we have to look at that part of the spectrum to also be able to make some inference that will also be important for us to be able to make a good justification of anything given to us. So, like I said, we have functional group region and we have the fingerprint region. But the major region that you have to most time consider is your functional group region, which is between 4,000 to 1,600. And I said this region usually contains the stretching vibrations, vibration, while this part contains bending vibration. So those are the major. And I said the stretching vibrations have to do with the bond length, while the bending vibration has to do with bond angle. But a bigger focus will be on this region, even though we still have to consider some signals that can also be found in this fingerprint region also. But this is the basis for reading your IR. So you must try to identify the functional group and you also know the fingerprint region. So how do I read the IR spectrum? So I'm going to be giving us some specific things that we can always look out for anytime we are giving an IR signal. So let's try to follow. Now, these are some of the things you have to look out for in an IR spectrum. Now, so I'm going to give us different signals that we can always look out for in an IR spectrum, what they represent, and at the same time their meaning. So to start with, the first thing that should always, the first point you can always look out for in your IR spectrum is the 3,000 per centimeter region. So in this region, you can always use this particular region to determine whether your compound contains sp3 carbon, whether it has sp2 carbon, or whether it has an sp carbon atom. So I'm going to be giving us notable signals that we have to always use. So if you have a signal just below 3,000, just below 3,000, So what it implies is that, so what does a signal just below 3000 per centimeter represent? It represents that you have an sp3 stretching vibration. That's what this represents. A signal just below 3000 represents sp3ch stretching vibration, and it implies that you have sp3 carbons. You have sp3 carbons in the what? In the compound. So we know what sp3 carbon implies. That is carbon that have four single bonds around it. So that's what that implies. Now you can also have a signal just above 3000. So the question is, what does this also represent? It represents that it represents sp2 CH stretching vibration. So now you see a signal just above probably around 3010, 3100. You see the signal around that point. It represents your sp2 CH stretching vibration. And what that implies that you're having an sp2, let's say carbon in the what in the system. Now, but there are different systems that can have, or let me say, there are different class of compound that can have your sp2 carbon. For example, when you look at aromatic compounds, they always have an sp2 carbon. When you look at your alkenes, they always have an sp2 carbon. So it implies that if I'm saying a signal just above 3000, the compound can be an alkene or the compound can be an aromatic compound. So how do I differentiate between these two? I'm also going to mention that earlier. Another thing also, you can see a signal far above 3000. Now a signal far above 3000 implies that you're having an SPCH stretching vibration. And what does this imply? It means you are having your SP carbon in the compound. An SP carbon is a carbon that has a triple bond. An sp2 is a carbon that has a double bond, while sp3 is the one that have only single bond around it. So the signal for above 3000 should be very sharp, because you can have a lot of signals for above 3000. Now, there are different means by which you can always confirm whether what you have here, they are true, they are, let me probably say true. So if you have an SP, probably you see a signal just above 3000, and you want to check if certainly it is an sp2 carbon, or probably let me say a carbon that has double bond. There's always a signal you can always check out for. For example, if you see a signal, so you can always confirm a signal just above 3000, which represents your sp2 carbon being present in the compound. You can always establish that by looking for a signal at 1006. A signal at 1600 per centimeter represents your C double bond C vibration. But if it is exactly at 1000, it represents that you have that the sp2 carbon is in an aromatic system. It's in a ring in an aromatic system. So if you see a signal just above 1600, that also represents your C double bond C stretching vibration. But in this case, it will be an sp2 carbon, sp2 carbon is in an alkene. So it now depends whether you are having an sp2 carbon in an aromatic system, or you are having an sp2 in an alkene. Depends on whether you are having a signal at exactly 16, or whether you are having a signal just above 1600. When I'm saying just above 1000, I mean that implies that probably having a signal around 1600, in between 1600 and 1650. So that's what this implies. Now, the next one I want to talk about is to talk about the sp carbon, that is your carbons that always have with your what, your triple bond. That's all. So there's also a way for you to also confirm if you're having a sharp signal far above 3000. there's always a signal you can always also check out for to also confirm this. And that signal is always, you will see a signal at around at um, at let's say 2002, at around 2000. So a signal at 2002 represents your C triple bond C stretching vibration. So that's so if you see, for example, so because the thing is, the way they will ask the question is for you to highlight the signals that you can have in your spectrum, at the same time tell us what each of them represents. So the signal at 2000 represents your C triple bond C stretching vibration. That's what that implies. And you can always use this signal to establish that the sharp signal above, far above 3000 that you see, that you can probably see in the world in the spectrum, represents your SP carbon. So when you see this signal, this can always be used to establish this. So at 2200, is that signal actually represents your what, your C triple and C stretching vibration, which implies that you are having, which probably implies that you are having, certainly you are having an SP carbon. Now, so if I could not find any of these things from this place to this place, I could not find all of this signal in a particular IR spectrum, it implies that the compound given to me is certainly a saturated compound. So having these two means that the compound you are having is unsaturated. If you are having a signal just above 3000 or far above 3000, it implies that the compound you are given is not unsaturated. But if all of these are probably not there, that means that and you are only having a signal just below 3000, it implies that the compound represented by the spectrum is a saturated compound. In the next lesson, I will try to give you more about other things you can also look out for to be able to know what class of compounds you are having in an IR spectrum. I want you to continue to watch, at the same time share with friends or yes or your colleagues that can also be in need of these lessons. And if you have your questions, you can always drop your questions in the comment section. Like I said, I hope you will subscribe to this channel and share with friends which you know this lesson can be of help to them. Thank you for watching.